For lesson 2.2, what we're going to do is revisit the concept of the derivative. And if you look in the handwriting off to the left-hand side, you're going to see two little phrases, the slope of the tangent line and the instantaneous rate of change. What you need to be aware of is that the derivative, whenever we talk about the derivative of f, and a lot of times we will abbreviate that as f prime, f, the little tick mark up there. What we're really talking about is the instantaneous rate of change of f with your y value with respect to x, but it's also representing the slope of the tangent line. Now, we saw a limit definition in section 2.1, and that's what we've highlighted right up in here. F prime of x, that derivative, the slope of the tangent line, or the instantaneous rate of change, is the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, in 2.1, we actually had the letter a representing x, but we can definitely interpose those two and use an x instead of an a. This is provided that this limit exists, that we'll find the slope of the tangent line or the instantaneous rate of change. If our limit does not exist, the derivative doesn't exist, and we would say f is not differentiable if that's the case. The alternative definition, and actually this is our first definition that we use on the notes of 2.1, is that f prime of a was the limit as x approaches a of f of x minus f of a all over x minus a. So the slope of this tangent line and the instantaneous rate of change is what we are finding. So let's go back. This is actually an older problem right now with example 1. And it says, given that you have this function, and you can think of this as f of x equals 2x squared plus x minus 3. Let's find the slope of the tangent line at a particular point at 3, 18. Well, let's use this definition that we see on top of the screen here, that f prime of a, and a is some arbitrary x value. We'll have the limit as x approaches a of f of x minus f of a all over x minus a. Now the fact is we have our function, and the function f of x, thank goodness, is plain and simply 2x squared plus x minus 3. If we were to substitute in f of a, remember we could have f of a blank and say that's 2 blank squared plus blank minus 3. Plug an a in there and you would get 2a squared plus a minus 3. And down below we'll just have x minus a. So I'm going to continue this limit right over here, and I'm going to distribute the negative in that subtraction. We want to subtract every little bit here. So I'm going to say minus 2a squared minus an a plus a 3. Down below we have x minus a. And I hope you can see quickly that the minus 3 and the plus 3 are going to cancel out. But sure enough, if we were to substitute an a into this limit, your numerator will collapse to 0, as will your denominator. And 0 over 0 is not very helpful. What we need to do is investigate this a little bit further. So tell you what, I'm going to group the 2x squared and the minus 2a squared together, because it certainly looks like we can do something there. Maybe do some algebra. Then we'll say plus x minus a all over here as well. And we can definitely do a little bit of factoring. I'm going to take this 2x squared minus 2a squared and factor out a 2. Now if we did that, I hope you can see very quickly that x squared minus a squared is also going to look rather familiar. You can think, well, wait a minute, couldn't I do some factoring there as well? You know what? We can, thank goodness. So I'm going to continue working up over here, and I'm going to have my 2 out in front, but then I'm going to factor x squared minus a squared to get x plus a, x minus a. And then we also have our plus x minus a over here. Now right now we could do one of two things. We could either do an I Heart Math and do some simplifying, or we could factor out x minus a from the numerator. And that's actually what I'm going to do. I'm going to pull that x minus a out in front. I'll be left with 2 times x plus a. I'll say plus, well, I'll have a 1. Factoring really means divide out an x minus a. You could double check and see that you're right by redistributing x minus a. But your x minus a's are going to cancel, leading us to this limit as x approaches a. If I were to plug in that a, I would get 2 times a plus a, which is 2a itself, and 2a times 2 is 4a. So really understand what we just found. We found that f prime of a is equal to 4a plus 1. Now I do want to point out we're not done. We're not done because they're not saying find an arbitrary tangent line slope. They're saying more specifically, we want this to be at 3, 18. Well, that means your a is 3. So if I did f prime of 3, we'd get 4 times 3, which is 12, and 12 plus 1 is 13. So what is the tangent line slope at the point 3, 18? The answer is the tangent line slope is 13. For part B, where is the tangent line horizontal? Well, your tangent line slope we just found to be 4a plus 1. And what you can do very quickly is realize horizontal lines have slopes of 0. We had the acronym HOI in Algebra 2 and all throughout your math classes to tell you that horizontal lines have 0 slope. They always have y equals an equation. Y equals some number. So if I were to substitute this in, if I said 0 equals 4a plus 1, if I were to solve, if I were to minus a 1, negative 1 is equal to 4a, and a would equal negative 1/4. So when is the tangent line horizontal? When your x value is negative 1/4. And, you know, if you wanted to find the actual point, you could go ahead and plug in negative 1/4 into the original equation, and then you could find the y value as well. You might have noticed, though, as we were finding tangent line slopes or instantaneous rates of change, that was a little bit of work. Thank goodness we have shortcuts. What we have, and this is going to be very, very helpful, when you have y equals mx plus b, of course you have a line with slope m. If I were to draw a tangent line on top of that line, you would really have the same exact line that you started with. Meaning, what is the slope of the tangent line? Plain and simply, it is m. What if you have a horizontal line? Y equals some value, like y equals 3. Well, we just saw from Hoy that the derivative, the tangent line slope, would be 0. But right here is maybe the most helpful shortcut for taking a derivative. This is known as the power rule. If you have x to the n, the derivative is bring your n down, bring that power down in front. Then you'll have x raised up to n minus 1. And that's wonderful. When you have that, you will be able to get the tangent line slope without having to do all that limit work. So look, if we were to look, for example, at x to the fifth, yes, we could do what we did in example 1 to find the tangent line slope. Instead, let's go ahead and take our power and bring it out in front. Now my new power, I'm going to subtract a 1. 5 minus 1 is 4. You might say, well, what about over here with this next example, 4x to the 8th? Well, take your 8, bring it down in front and multiply it, and then you'll have x to the 7th. Go 1 power less. 4 times 8 is 32. And listen, you'll be able to just multiply those powers in your head, multiply those numbers in your head. You don't have to literally write out 4 times 8. Look, if I give you x to the negative third, though, that's what 1 over x to the third is. Bring the negative 3 out in front. Subtract 1 from negative 3, you'd get negative 4. Negative 3x to the negative fourth would be your derivative, your tangent line slope, or your instantaneous rate of change. This could also be written as negative 3 over x to the fourth. To wrap up, let's say you have x to a fractional power. Thank goodness you do the same thing. Take that fraction down in front, and now your new power will be your fraction minus 1. So for example, if we had the cube root of x, which is really x to the 1/3, bring 1/3 out in front. 1/3 minus 1, well, 1/3 minus 3/3 would be negative 2/3. Look at that. How about this? If you've got a square root that's an index of 2, this is really x to the 3/2. Taking a derivative, take 3/2, bring it out in front. Subtract 1 or subtract 2 over 2. You'd be left with just a new power of 1/2. Look at this, 1 over the 5th root of x. Hopefully we all agree this is really x to the negative 1/5. Take negative 1/5, bring it out in front. Now subtract 5/5 from 1/5. You'll have negative 6/5. These shortcuts are fantastic. They're going to save you plenty of time and effort because you won't have to use the limit definition. Of course, what are we finding? We're finding a new equation, this f prime right here, that when I plug in an x value will tell me what a tangent line slope is. Like for example, here's just some arbitrary curve. You might say, well, what if I wanted to draw a tangent line slope somewhere? Just plug that x value in and you'll know what your tangent line slope would be. Well, hope this is helping. Good luck.